Today we are going to talk about chapter 6 lor. So I think for today I'll go for 6.1 and 6.2 first lah. Okay, so 6.1 all you have to know is physical and chemical changes. So physical changes is actually change of the states of the matter. So it be it solid, liquid or gas lah. So physical changes for example you have boiling condensation freezing and so on lah. So these physical changes can be easily reversed. So we can go from solid to liquid and then straight away go back to solid also. This is why we say it is easily reversed. Chemical changes, it is hard to reverse. And then this one for chemical changes is actually when we mean chemical changes it actually means that some of the chemicals undergo this reaction and then a new substance is formed lah. So this one we have two types of chemical changes, exothermic or endothermic. So exothermic exo is out, endo is come in. So exo heat is released lor, thermal energy is released. For this one is for bond formation one. Endothermic is bond breaking. Okay. This one exo and endothermic last chapter we already learn chapter 5. So I have to look back to the notes lor. Okay. 6.2 is rate of reaction. So rate of reaction this one is, okay, you need to know what is a successful or effective collision. So this one you have two conditions lah. One is the particles are colliding in correct orientation, and then secondly they have to achieve the activation energy. Okay, and then the next thing you need to know is about catalyst. Catalyst is just like the enzyme that you learn lah. So catalyst, their function is to increase the rate of reaction by lowering down the activation energy of the reaction. And then the other characteristics of catalyst is it is unchanged at the end of the reaction lah. Means that the catalyst is still there lah after the reaction. They won't be used up and then they can be reused lor, just like enzyme. Okay, factors affecting rate of reaction. Listen, you have 5 factors. The first one is concentration of solution. Okay, this one, concentration of solution, we relate it to number of particles per unit volume. So if the concentration goes increase then the number of particles per unit volume will also increase. And then after that, this one will make the particles to collide more frequently. That's why frequency of collision between particles increase. These particles I write bracket here because you have to mention which kind of particles is it when you are explaining in the question paper. Okay, after we talk about the frequency of collision we talk about the frequency of successful collision, or you can write successful collision rate also can. If the frequency of collision is increased already confirm the collision rate, the effective or successful collision rate will also increase lor. And then after that, rate of reaction increase. Okay, second one is gas pressure. For gas pressure if the pressure is increased means that they will push the particles towards the same side So this one the number of particles per unit volume will also increase lor. This one is actually concentration increase lah. And then after that, frequency of collision, successful collision rate, rate of reaction, these three all the same only. Increase, increase, increase. Surface area of solid. This one is that when they decrease and then rate of reaction increase. So because if they decrease the surface area the total surface area exposed is actually increased So you see this one 2 cm, 2 cm, 2 cm. This one is 8 cm cube And then the surface area 2 times 2, and then we have 6 sides. So 4 times 6, 24 cm squared. This one is the surface area. Let's see here. 1, 1, 1. But they are separated into 8 cubes already. So this one, each side is 1 cm cube 1 times 6 and then times 8. You get 48. So this one, total surface area is larger So when the total surface rate is increased already the frequency of collision, successful collision rate, and then rate of reaction will also increase. Fourth one is temperature. So when temperature increase, the kinetic energy of particles will also increase because they will have more energy to move already and then same thing frequency of collision, successful collision rate, rate of reaction will also increase. Lastly, the catalyst. When we add catalyst, the catalyst they will create an alternative pathway that is actually only require a lower activation energy. So these particles they will achieve this lower activation energy more easier more faster. So the frequency of collision, successful collision rate, and rate of reaction will also increase. Okay, let's see here. This is how we investigate the rate of reaction So we use different methods. Actually, they are all more or less the same We use different methods for different factor only. Okay, so this one, the first one is surface area So this one we use hydrochloric acid and calcium carbonate chips or calcium carbonate powder Okay. Add the hydrochloric acid into conical flask, and then after that, this one is a delivery tube. This one. Deliver it to measuring cylinder with water Okay, this one is downward displacement. Okay, and then after that, we add the calcium carbonate chips into here and then see how the reaction occur, how fast or how slow So we'll measure the gas volume using this and then after that you repeat with different sizes of calcium carbonate chips. You have lumps, means larger than chips and then crushed means that they are smaller than chips but not like powdered. Powdered is everything is powder already So this one you will, in the end you should know that the smaller the size of chips they will cause an increase in surface area and then surface area of particles exposed to others increase already. So frequent and successful collision and the rate of reaction increase. Okay, this one is for another factor lah. This one is concentration. So for concentration, we use Na2S2O3 and then add HCl into them, hydrochloric acid, and then we have to draw a cross on the paper, and then we add in the thing, and then after that we'll have to like and then you have to know check when does the cross cannot be seen from the top of the conical flask. Okay, and then after that we use different concentration by adding different volume of water . Okay, this one, temperature. For temperature, dilute HCl is heated to a set temperature using water bath. Okay, and then after that add them into conical flasks. After that, we add the magnesium strip and we start the stopwatch. Stop time when magnesium fully reacts and disappears. And then repeat with different temperatures . So this one follow back the one that I taught you how to explain . When temperature increase, kinetic energy of particles increase, frequency of collision, successful collision rate, and then rate of reaction all increase. Lastly, effect of catalyst on rate of reaction. So this one, you add in H2O2 first, hydrogen peroxide, and then after that use delivery tube. More or less the same setup but just that this one is hydrogen peroxide solution, and then after that we add in catalyst. This catalyst is actually magnesium 5 oxide. So we do two sets . One is with the catalyst, magnesium 5 oxide, 4 oxide. The other one is without the catalyst. Okay, and then when they ask you to explain, just write catalyst, change the name to magnesium 4 oxide. In this case, creates an alternative pathway requiring lower activation energy. Particles achieving the lower activation energy increase. The frequency of collision between particles increase. Successful collision rate increase. Rate of reaction increase. Okay, so that's all for 6.1 and 6.2. Okay, see you in the video for the exercise .